Okay, so this is the first video for section 1.6, which is over solving different types of equations. So this video is going to cover how to solve rational equations, which are just equations with fractions, more specifically when you have a variable in the denominator. Okay, so to solve these, our goal is to get rid of the fractions. And so we can do that by multiplying everything in the whole equation by the least common denominator. So when I look at the fractions, I have a denominator with a 3, and then also a fraction with the denominator of the factor x minus 1. So the least common denominator for this particular equation would be 3 times x minus 1. Okay, and I'm not going to multiply that through. That's not going to really help me much. And so what's going to happen is I'm going to multiply. I'm just going to rewrite this original problem, and I'm going to multiply each fraction by the LCD. And since it's not a fraction, I'm going to just put it over 1. So that should be 2x. And even the other side that doesn't already have a fraction, I'm still going to multiply that by 3 times x minus 1. Okay. All right, so what I'm doing, and the purpose of doing that is what I'm looking for is for the denominators to always cancel out. So for example, when we look at this first fraction, the 3's cancel. So the only thing that we have left is x minus 1 times 3x minus 1. And so we'll come back and FOIL that together here in just a minute. Then I get to the second fraction, the x minus 1's cancel. So I have 3 times 2x. And then on the right side, nothing's canceling out because there's no fraction. So we're going to have to multiply everything together. So it's going to be, again, I'll come back and multiply all this together here in a second. So that first step, after you find the LCD and multiplying everything by that LCD, the whole purpose is to cancel out all of the denominators. And so now we have an equation where there's no fractions. Okay, so the next step is just to go ahead and multiply things together. So I'm going to FOIL these binomials together. So I'll have 3x squared, negative 1x, negative 3x is a negative 4x plus 1. And then here, negative 3 times 2x is a negative 6x. Then on the right side, I'll take 3 times x, which is 3x, and distribute the 3x, which gives me 3x squared minus 3x. And now we're just trying to solve for x. Now, as you do these problems, what's going to happen is you're either going to get a linear equation or it's going to be a quadratic. So once you get everything multiplied together, you want to decide do you have a linear or quadratic. And it looks like it's going to be a quadratic at first because we have an x squared. But if you think about if we were combining these or if we subtracted both sides by 3x squared, they would actually cancel out. So it actually turns out that this is going to be a linear equation. So, well, anyway, if I go ahead and simplify this side, I'll get negative 10x plus 1 equals negative 3x. And since it's linear, it just means I'm trying to get x by itself. So I might add 10x to get 1 equals 7x. And then divide both sides by 7. And that gives us x equals 1/7. And so that's our solution. Okay. Now, the other thing that we have to be careful about with the rational functions is that if our answer causes the denominator to be 0 in anywhere in the problem, then it can't actually work as a solution. So sometimes you'll get an answer, but the final answer to the whole problem will be no solution. Okay, and so you have to think about if 1/7 would be an excluded value. Well, it's not. 1 is the only excluded value in this problem because if I put a 1 in here, we would get 0. But if I put a 1/7 in here, obviously we don't get 0. So as long as I don't get 0 in the denominator, then we're good. So that's our final answer for that one. All right, so let's take a look at second problem. And so in this case, to get started, you might notice that this polynomial right here, this denominator is not factored. So we want to go ahead and factor that. We can do that by taking out a GCF, which is x, which leaves us with x minus 2. So the LCD for this particular problem would be x minus 2. Then we have an x, which is a distinct factor, so usually right down the front. And then we get over here and we already have the x and the x minus 2, so I don't have to repeat those factors. So that's our LCD. We're going to multiply everything by x times x minus 2. Okay? All right, so if I rewrite everything, there's my LCD times the first fraction, which is 3x plus 2 over x minus 2. Then multiply the LCD over 1 times the second fraction. And then also the LCD over 1 times the last fraction. Okay, and you might notice that I wrote this denominator in factored form. It's going to be easier if we do it in factored form. Okay, so as we go through, looking for things that we can cross out. So when I multiply these first two fractions together, the x minus 2's cancel. So I'm going to take x times 3x plus 2. I'm going to go ahead and multiply that at this step. Gives us 3x squared plus 2x. Next set of fractions, the x's cancel. So I just have x minus 2 times 1, which is x minus 2. Then on the other side of the equal sign, the x's cancel and the x minus 2's cancel. So we just are left with -2. All right, so in this case, we have a quadratic, and this x squared is not going to go away. So this time, because it's a quadratic, we want to get everything equal to 0, and then either factor or use the quadratic formula or whatever method you want to use. Okay, so oops. All right, so I get 3x squared, 2x plus 1x is 3x. And then if I add 2 to both sides, then I get 0. Okay. So I can factor out a 3x, a GCF, which gives me x plus 1. And then we would take each factor and set it equal to 0 and solve. So I get x equals 0 and x equals -1. Okay. So these are two potential answers. They could both work, but remember what I said on the last problem, we've got to go back and make sure that none of them cause the denominator to be 0. So if I put 0 into this denominator, that's a problem because I get 1 over 0, which I can't have. Okay, so x equals 0 is an extraneous solution, which just means it's not an answer. Okay, but -1 works. Okay, I could put -1 here, -1 here, -1 here. I'm not going to get 0. So the only answer in this case is just -1.
In our next example, we're going to look at work rate problems. We have two equations here. The top one, R equals 1 over T, where R is the rate of work and T is the time that the job can be done. For my second equation, A is the amount of work completed, R is still the rate of work, and T is the time worked. For example 3, we have the following word problem. One printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? Okay, the first thing we need to do is assign variables. I have x as the time it takes the fast printer to do the job, and 2x as the time that it takes the slower printer to do the job, because the problem said that it takes 2 times the amount of time that the fast one takes. Next, we're going to use the equation R equals 1 over T to find the rate of each of our printers. So the rate of our fast printer is 1 over x, and the rate of our slow printer is 1 over 2x. Now we are ready to set up our table. The rate for our fast printer and slow printers go there. The time is 2 hours for the job. And now we are using the other equation, A equals R times T, which tells us the amount of work completed. So I did my rate times time for both the fast and the slow printer. The idea of the equation that we're going to write is pretty simple. It's just what part of the job did the fast printer do, which is 2 over x, plus what part of the job did the slow printer do, which is 1 over x, equals 1 because in the end it's one whole job. In order to solve this equation, since I have x's in the denominator, I'm going to just multiply each term by x to get rid of those fractions. That leaves me with 2 plus 1 equals x, so we have x equals 3. And now we're ready to state our answers. The fast printer can do the entire job on its own in 3 hours, because remember, x is the time it takes the fast printer. And the slow printer can do the whole job on its own in 6 hours, because the time for the slow printer was 2x, so 2 times 3 is 6.